Hello students, welcome. In this problem, we are going to learn how electric field and electric potential they related each other. We know from the definition, electric field, it's a vector quantity. It is a negative gradient of potential, electric potential. Do you remember or not? So now I can also write that in simplest differential form, that dV by dr. Don't forget what is dv, that is change in potential, electric potential. Dr is change in position. Okay, here dr is x comma y comma z, but here as per this problem, so they gave only for x axis, so I'll take, instead of 3 axis, I'll take only one axis, that dv by dx. I can write like this. So this clearly shows that from v versus, what is this dv by dx? So this is nothing but, this is negative slope in v versus x graph, right? So like electric field is negative of slope of curve in v versus, okay, this is nothing but slope of curve, this is slope of curve in v versus electric potential versus x graph. Okay, now you see that first question. So electrostatic potential as a function of x is given. Calculate the corresponding electric field in a region A, B, C, D in first graph. Like two figures are given, A and B. Okay, so A and B. So I have first figure and I have second figure. In the first figure, they are asking in A. So here A and B. Here B. In C. Here C. D. D. At this point, what is electric field? I know the relation. So electric field is nothing but what? It is a negative slope, right? So I should find out slope. My problem is simplified. Now I'll take one by one. First A. At A, I want to find out, right? What is the electric field at A? Now you just see, this is a straight line, right? So there is a change in both x and y axis. So here in y axis, what is the change here? Initially it is 8. Then finally it becomes this point. So here to here, right? So this is nothing but 8 to 5. So the slope E is equal to minus of, that is del V. What is del V here? That is 5 final minus initial, 5 minus 8 divided by, that is along x axis, sorry, y axis. What about x axis? Initially it is 0, finally 0.2. So 0.2 minus 0. So now you see that, that is minus, don't forget already one minus is there, minus of minus 3 by 0.2. So what is 3 by 0.2? I'll write it as plus 3, it will come. So I'll write it as 3 divided by 2 into 10. So this is also 30 by 2. I'll have 15 units. Don't forget what is the unit of electric field. So in terms of volt per meter. So this is the answer for, this is electric field at A. Same way I can find out B. So by observing itself, you know that, right? It's decreasing graph, okay? And decreasing graph, like I have here straight line. What is the slope here? Here there is no any change in y axis, right? Only x axis changes. So what is the slope? I know that already at point P, that electric field is minus of final is also already, both are in fine 5. So I'll write here 5. So 5 minus 5, 0. So slope is 0 overall, whatever the number, whether you are multiplying or dividing, electric field will become 0. So this is second. Now C, you just see at point C, I can write here. So I'll write here at point C. So you just observe the graph at point C. Again, what I need is a 2 point, y axis, x axis. Here what is the change? That final is 7 minus 5. So 7 minus 5 is 2. That is change in potential across y axis. So what about x axis? Here 0.4, 0.6. So electric field is minus of 2 divided by, what is the difference? 0.6 minus 0.4, that is 0.2, right? So this is nothing but how much? Minus 10 volt per meter. So minus comes, and this is at C, and what I have is that D. So electric field at D, electric field at D is equal to, again I should find out this graph, right? So I should solve this. So here you take, so initially here find this point. So this is 0.6 to 0.8. So 7 to 1. So what is the difference here? 6 along y axis. What is the difference here? 0.2, correct? Apo minus of, don't forget the final is small, so if I write that properly, 1 minus 7, so it is going from where, so 7 to 1, so final minus inertial, 1 minus 7 divided by 0.2, so minus minus, it will become plus, so 6 by 0.2, this is nothing but 30 SI units, 30, so I'll write, yeah, 30 volt per meter. That is answer for D. So here electric field is 15, 0, minus 10 and 30. Note this point, whenever the electric potential decreases, okay, electric field is plus. Whenever electric field is increases, electric field is minus, and if it is not changing, electric field is 0. Potential is constant, electric field is 0. Note this point, okay? This is very, very important. You know why it is. So you think about it. Now next problem. They are asking us to plot a graph for this. So you see that is this V versus X graph. In this, again I should find out slope. What is the slope here? Slope is final is greater than initial, right? So 30 divided by 1. So 30 divided by 1, so is equal to minus of slope. Minus 30. So here the graph minus 30. Then 1 to 2. So here this is 0 to 1. 1 to 2, you see that the slope again 32, again it is going to 0. So change is minus 30 divided by 1. So already there is a minus, so it will become plus. So this is plus 30. And 2 to 3, I have straight line 0. So it is 0, 2 to 3. And again you see that this is going from here 0 to minus 30. So 0 to minus 30. Minus minus, it will become 0 minus minus 30. This will become plus 30 divided by 1. Again I have positive. Then again it is minus 30 to 0. So minus 30 minus 0. I have minus. So I will have here 4 to 5. 4 to 5 is minus 30. Are you following this? So this is the answer for both the questions. Thank you.